Hi, thanks. I guess as it's obvious now, I'm here to talk about building web services with Go. Something that I've done quite a bit of in my work at Betable so far. So my name is Richard Crowley. As they said, here's how you get a hold of me on the internet. And this company, Betable, we're a gambling operator. It's gambling as a service, and I've got dibs on the blackjack guy. We're a licensed, regulated entity, and we build a platform so that other game developers don't have to worry about the math or the money or the legal parts and get to just do what they do best, which is, of course, build games. And we build a lot of web services. We have, at this point, I think, more services in production than we have engineers working on them. So we went to the kind of extreme side of service-oriented. And actually work? Do I look completely awesome? So let's try to put a definition on service. It's a set of data and a set of operations that you can do to that data. What makes it a web service is that it's accessed over the network over HTTP. It's not something local or in memory. And what makes it a web service and not a web application is that it's based on structured data that machines can parse and make decisions about, something that is part of a larger system rather than what the end user sees necessarily. And so this is the most basic, silly web thing in Go, and I would argue it's not quite a web service yet, but we're going to get there. So hello dub is just a function that's registered with the HTTP library, and then we serve it on port 8080 and we call it a day. And there's a curious thing about all this, underneath the fact that it's a closure and that we're calling handle func, whatever that is, and that we give it slash as a route, there's this method signature that's noteworthy. It looks kind of Go-like. It has a response writer, which, the response being the output, it's sort of that outputs before inputs pattern in the arguments. And it's this response writer thing, which incidentally is an interface, and some folks don't realize, and then a request. And this is our baseline for handling an HTTP request. And it just so happens that this interface is the HTTP handler interface. It's the baseline from the standard library, and when you put it in the form of an interface, they call it serve HTTP. And this is going to come up over and over and over again. And I know that we're programmers, so that our first instinct when we see a really simple interface like this is to just build more stuff on top of it. And that's great, because that stuff has to be built. But I would encourage you, and I'm going to try to convince you through the rest of this talk, that this lowest common denominator here, this handler interface, is what all Go web services should be built from. It's what allows composability and interoperability and separation of concerns that makes Go great. So I encourage you to embrace this interface and don't soil it up too much. So let's rewrite the hello dub service that we had a minute ago in terms of this new handler. So now we're gonna have a type called handler, and we're gonna implement the serve HTTP method. And it's the same as before. We just fprintline to the response writer, which of course is a writer, and that's how all that works. And I went ahead and added setting a content type header and being explicit about the response status, just so we can see how all of that fits together. And at this point, we don't really have a web service, so let's turn it into one. And of course, if we do that, we JSON, because that's all we mean by web services these days anyway, right? So the change is pretty minimal. We've changed the content type to be application JSON, because we're good citizens in the HTTP land. And we've traded out just writing to our writer to wrapping it with a JSON encoder, and then we encode an object that I just made up into JSON, and that's what actually gets written out to the browser or the client or whatever. The unfortunate thing here is that because we're encoding JSON, because maybe we have UTF-8 problems, there's a possibility that we have an error still, and so we've kind of muddled the problem of just writing an object out to our client, and that's kind of unfortunate. Now, it's interesting also to note that an error response in terms of HTTP and Go is relatively indistinguishable from a successful response. This is almost exactly the same code as we saw a moment ago when we replied 200 OK. But this time it's a 500, and of course that's the worst possible thing that can happen in the world. The real problem is that there's no error value. So this doesn't feel like an error condition from the Go source code sense. And that's a little bit unfortunate because it's kind of an impedance mismatch between the language that we're speaking with our clients and the language that we're using internally in our software. So we're going to come back to later how to bridge the gap and make Go errors into HTTP errors so that everybody kind of gets on the same page. What we're after here is this, where we have functions that return errors, or maybe they return something else and an error. And we use that error not to explode like an exception, because the errors are not usually exceptional. They're merely our opportunity as the programmer of the thing being called to express what happened to the caller. Perhaps what happened is that what you expected to happen happened, and so you return a nil error to say everything's fine. But it's still an opportunity to tell the caller what happened, perhaps how to recover, perhaps a little more detail about their bad inputs or the terrible state of the world that caused it to be that way. So, you know, don't just return an error string that says fail. That's not super helpful, even though that's exactly what I did here. So back to the HTTP stuff. We've got this handler interface with its serve HTTP method, and it seems like that's sort of the end of the road, that it's such a simple thing that we can't express all the things that we'd like to do with the web service, which usually actually becomes a lot of different things, a lot of different operations of data. And the answer to that is actually pretty simple. The handlers are a tree, so to speak, that handlers handle other handlers, and it's passing on and on and on down. And so some of them end up multiplexing to various handlers, depending on URL prefixes or header values or what have you. Some handlers serve static content. Some handlers gzip the request or unpack gzip the response or unpack the request from some bizarre format. And we can build a lot of interesting things with these handlers. And so a model of doing this is I've expanded once again our base HTTP example here, and I've added in the serve mucks from the standard library, which the first couple of lines there are bringing back the very original example where our handler that we define the serve HTTP method on is being registered at the /URL so that that path is what gets routed to our handler. And of course, we could add lots of different paths there and have handlers that react to any number of things in the request, the headers, the time of day, whatever you like. And then we've expanded a little bit further at the bottom to separate out what was before. It was just listen and serve, and now we've got listener, and then we serve from that listener. And so this is actually starting to beg the question: how reliable is this stuff anyway? Can we trust the HTTP server that's in the standard library? Raise your hand if you've been burned by Ruby, by Python, by anything else that has a crap web server in the standard library. Yep. So we need to see if it's up to the challenge. And of course, if you came to the meetup a couple months ago, you saw Brad talking about how it definitely is. And here's briefly how. So think about an echo server that's, you're dealing with the network directly, where you listen, and then what do you do logically? You get into a loop where you accept connections and then handle a bunch of connections in parallel. And in Go, how we do that is we accept connections in our accept loop, and then we go handle that connection. And that spins it off out into the background. And the great thing is that we can have thousands of them. So in our handle function that's off on its own, we just, in our echo server, read, write, read, write, read, write all day long. We don't have to worry about whether we've read enough and whether we have a complete request and whether we need to yield to the next guy because we only have 5 threads because Apache. It's simple. It does what it says on the tin, and that's fantastic. And the bonus is, of course, that it works at a large scale. So now that we've got a good web server and we don't have to solve that problem anymore, people like me get back to the next thing to do, which is to make web frameworks. And they're great. right? They keep us from repeating ourselves. You know, how much code did Rails save you the first time you used it, right? They keep us from repeating ourselves. They keep us, they build powerful abstractions that make it easier than just, you know, writing a web service in C or something. But often a web framework requires you to make a full buy-in, to give your entire world over to them. And that's a little bit problematic. So the problem there is that often that full buy-in comes with a lot of magic that you don't necessarily understand or even want to understand. And in Go, often those sorts of frameworks are incompatible with the basic HTTP handlers that I'm telling you that you should really be embracing. So that's the story that led me and some coworkers to develop what we decided to call Tiger Tonic. And it's a set of handlers more than it is a web framework. And it's inspired to a great degree by Dropwizard from Javaland, though Go's strengths allow it to look very, very different. Incidentally, the name is inspired by the same webcomic that spawned Dropwizard, so that sort of made sense to me. So I want to talk through a couple of the things that it does and how they work so we can really drive home the point that HTTP handlers are all you need to get anything done. So the standard library servmux that we saw a little bit ago is great, but it only routes prefixes. So you can't do intricate routing without managing a tree of handlers on your own. So the try servmux, I say it Knuth's way, sorry, allows you to get a little bit more surgical with your handlers without managing that tree yourself. And so we say that we want to get foo bar baz, where bar in braces there is a parameter that gets expanded, so it's foo/123/baz, and we're going to have a URL parameter to get that 123 out. And because this is handling the full scope of the URLs under that mux, and the fact that it has access to the method, means that it can respond 404 and it can respond 405 like a good web service should. And just like the servmux, the standard library, this thing that comes out of here is nothing but a handler itself. So you can kind of recurse on yourself and use that over and over again. Under the hood, what it's actually building up that same tree that you would have to do on your own, but it's building it internally and doing the parsing of the URLs itself. And the leaves of that tree are the various that a particular URL responds to. And like I said, those wildcards are pulled out into the query portion of the URL. So they're available to you in your handler without any special syntax over top of the HTTP handler interface. Next thing that we, of course, want to do, we put a pin in it before, is speak JSON. And it was a little bit verbose last time, so we want to take a little bit better stab at it. And this is where we get to the bit about Go being statically typed and how awesome that actually is. Because what we can do is define functions with a slightly different signature. So in this case, it takes a URL, a header, and a request. And that's a structure that I define. And it has whatever properties it wants, whatever JSON tags it wants. And the request is deserialized into those arguments and passed to a function that I define. And then my obligation to that is to respond with a status, a set of headers if I feel like it, a response object, which again is a statically typed Go object that can be whatever I want, and an error, which in this case is nil, so we're all going to be great. And by wrapping that in the marshaled function, we're turning that back into a handler. And the magic of dealing with JSON, of dealing with the bad requests and the unacceptable requests and the unsupported entity type or whatever that whatever 415 is, all of those are handled by the framework, and the output is a handler that we can use wherever. So underneath here, the fact that this is actually letting us declare the request and response types ourselves means that this is not an interface in the classical Go sense, which is too bad because it means you have to get out the reflect package, but that stays neatly tucked within marshaled. And what it does is that it verifies that the function is of roughly the right shape at early runtime, and then it constructs all the arguments for you. So when a request is coming in, we create with reflect.new a new object of the type that you're expecting, and let the JSON decoder decode into that object, and then you receive nothing but the static type that you're expecting. When we do it with a response, it's a little bit easier because the JSON encoder is expecting an interface, and everything is an interface, so it's all happy still. We have a slightly different path for errors, and that's how we're going to get on top of this idea that we should be able to work with Go errors and let the framework deal with the fact that the users are expecting to see a 500 response with some descriptive body. So when we need to write out an error, we do roughly the same thing, where we set the content type, we set the status code, and we write a JSON body out to our response writer that says that there's some error by some name, and here's what it's all about in some description. And the write JSON error and its supporting functions are allowing errors to implement extra interfaces. So if you implement status code method, you can override what the HTTP response is going to be. If you override the name method, then you're going to have a different name for your error so that you can pick and choose whether you want to expose the names of your types or if you want a more generic, GTFO kind of error. It's all up to you. And from these primitives, which are all still just handlers, we can impose larger and larger handlers. So a great example that comes up all the time is wanting to conditionally handle a request. Say, you want to handle a request if you're logged in. So we pass a function that reacts to the request and either produces an error or doesn't. And if it doesn't, then our protected handler gets called. And this is purpose-built, for exactly what we're trying to do. Special case of the more general that we can chain middleware together, where we have a bunch of handlers, and they all do whatever it is that they want. So perhaps we try to enforce a rate limit, and if you're over the limit, we respond. Otherwise, we let it fall through to the next one, where we see if you're logged in and it's all valid. And if you're not, we kick you out. But if you fall through once more, we get to the handler that does actual work. So we have a great amount of code reuse here, and we're still left with this handler whose behavior is to merely call handlers until it finds one that responds. And underneath it, this is built up by having a response writer. Remember I said that that's an interface. It's a response writer that takes note of whether you call the right header method. And as soon as you do, it bails out. So we can keep building bigger and bigger chains of things. And what we're going to arrive at is a web service that we want to put into production. And what tends to be the problem when you get there, or shortly after you get there without realizing it, is that you have no idea what's going on. And people have thousands of solutions to this problem, from reading Apache logs to New Relic to everything in between, to trying to run your own graphite system, to just like having a guy sitting at a computer tailing. And all of that is great, but the framework can provide tools to make that easier on you. So in the really surgical way, where you have one problematic request or endpoint or something that you need very, very verbose logs of what happened. And we at Betable have been using the first one here, tigertonic.logged, which will log the full request and response bodies, headers, everything for every request. If you think I'm crazy, try it, you'll love it. And there's a function for redacting sensitive information because, of course, bodies contain things like credit card numbers, and that would be terrible to have in your logs. It's a bad day. For the more traditional among you, you can do Apache logged, and again, what we're building is a handler that wraps a handler and reacts to whatever's happened underneath. I think now there is actually a JSON logged version that will work with Elasticsearch and Logstash and stuff like that as well. So that's in the small. In the large, when you're dealing with millions, billions of requests, however big you want to get, you don't have time to look at all the logs. You need to be told where to look. And so you want to have counters of what your popular endpoints are. You want to have timers to know what's too slow. You want to understand where the 99th percentile is way out of line. You want to understand where the standard deviation of response time is just all over the place. And you get that not by sampling from log data that has timestamps in it. You get that by having the application time interesting portions of the application. You can be very selective about what you time or what you count and give yourself a lot more intelligence than just blindly saying, like, how fast is this web server? So, so that's for in production. Now, before you get there, you have to test your services. You have to know that they're going to work before you test whether they're going to work quickly. And so testing in Go is, I think we can mostly agree, pretty great. I actually have gotten to the point where I go write a test function to try something out sooner than I go to the play site, sooner than I go write a main function. And I think that's really, really cool. And with web services, you want to have that same sort of instinct that the easiest thing to do is to just do a request, the whole thing, and see how it works. So you can mock URLs, you can mock headers, and call your functions that you give to marshaled, which give you the sort of Go parts of tested. Or you can really big and ambitious, and you can just call the serve HTTP, the response recorder from the standard library, that would allow you to then make assertions about the whole body string or the headers or whatever happened to come out of your request. So that was a lot of pseudo self-promotion and talking about handlers. And there's a bunch of other stuff that's in the library that we've found useful, that other people have found useful, that all combine to be just a set of handlers that make building web services faster and more enjoyable. And I've been working over the past couple days on my one more thing, and I got there this morning. I know it's come up in conversation at this meetup before that graceful stop on the web server would be an amazing thing to have. And I have a proposal that is working within Tonic right now that basically how it works is group to a net.listener wrapper and a net.con wrapper, and that gives you the ability to close a listener and then later know when all the connections that were accepted by that listener have been closed. But that basically means that you're stuck waiting or for keep alives to finally up and die. And the aha moment the other day was that if you control through a response writer whether the connections send the connection close header on the response, then you can short circuit that and make it pretty quick. So now you can do a graceful stop without waiting on connections to die, but merely in-flight requests to finish. And so that is my proposal for how we make that work, at least without patching the standard library, which is probably still a better solution. So in parting, use HTTP handler, and everybody here is going to be happier because we can all interoperably use your components to make better web services. Take that and then build your abstractions up within that. But remember that mostly people are going to be wiring them together from their most basic components. And where possible, you can use those abstractions you build up to make the code feel a little bit more Go-like and a little bit less like a 500 is kind of the same as the 200. You can make your errors feel like Go errors, even though they're not really exceptional. They're just part of life. So there's a couple of links for anyone who cares. I would be remiss about saying, especially to Blackjack Guy, that if the gambling industry is at all interesting to you, if Go is interesting to you, hit us up at Betable. Thanks.